Hello class. Today we're going to look at index of refraction. So again, a couple things that we do need to be aware of and remember is that the speed of light in air is going to be that 3.0 times 10 to the 8 meters per second. This is something that you do need to know. And the speed of light in water is going to be the 2.25 times 10 to the 8 meters per second. So when it comes to refraction, you're looking at the change in speed of light at the boundary in a substance in which is what will cause that refraction. So as light changes speed, when it goes from one medium to another medium, that's what's going to cause that refraction or that bending of light. Something you want to remember that the larger the index of refraction, the slower the speed will be. And that helps you determine which way that light will bend away or towards the normal with regards to that. So index of refraction. When we look at index of refraction, we're kind of looking at the optical densities of the different substances we're looking at. So there are two ways to figure out that that index of refraction, or N, which is going to be how we represent that. And the first equation that we can use is N equals C divided by V, whereas C is the speed of light in a vacuum, that 3.0 times 10 to the 8 meters per second, which you will always know that doesn't change. And we're dividing that by the speed of light in the medium that we're looking at. Okay, and so that's how we can figure out refraction. So again, if we look at an example, so again, you want to make sure you identify what you know. So the speed of light in carbon disulfide is 1.84 times 10 to the 8 meters per second. So again, we know that V, right, the speed of light in the medium, which in this case is carbon disulfide, is going to be that 1.84 times 10 to the 8. And C we know, and N, the index of refraction, is what we want to calculate. So again, N is going to be C divided by V. We know C is that 10.0 times 10 to the power of 8 here, meters per second. And we are going to be dividing that by our 1.84 times 10 to the 8 meters per second. Okay, and so when we make that division, the easiest way here is that 10 to the 8 and that 10 to the 8 are going to cancel out. The units are going to cancel, and 3.0 divided by 1.84 is going to give us an answer of 1.63. An index of refraction does not carry units with it. It is considered to be a ratio. Okay, so our final answer here for the carbon disulfate, the index would be 1.63. So the second way to calculate that index of refraction it would be using the angle of incidence and the angle of refraction. So those if you were given that information, we could use that to calculate our index of refraction, and we could do that using sine angle of incidence divided by sine angle of refraction. Now that sine button, or that sin button, is a button on your scientific calculator, and you simply push that button in with the angle of incidence, and that will give you a decimal, and that you can then divide to figure out that index of refraction. So if we go through an example here, so again, we want to calculate that index of refraction, and we know that the angle of incidence is 15 degrees, and we know the angle of refraction is 11 degrees. So if we were to write this out, okay, so again, our angle of incidence is 15 degrees. Our angle of refraction is that 11 degrees, and obviously N, or the index, is what we're solving for. So N is going to be sine angle of incidence divided by sine angle of refraction. So if we plug in our numbers here, our incident was 15 degrees, and our refracted angle was 11 degrees. So again, when I type that into the calculator, sine 15 is going to give me 0.2588, and sine 11 is going to give me 0.1908. And when I make that final division, I end up with 1.36. Okay, so that will give me my index for vegetable oil as 1.63. Okay, so hopefully this helps. Thank you very much.